Hello everyone and welcome to this latest video discussion as part of the Tech Partner Program. My name is Shaun Leeman and I've been with the RICS for 6 years and I sit within the standards, regulatory and thought leadership part of the organisation. I work alongside Andrew Knight as the Program Coordinator for the Tech Partner Program, where we look at the impact of data and technology right across the built and natural environment. With over 110,000 RICS qualified professionals working around the world and across the property lifecycle from land, planning, development, construction, valuation, property management, and even up to end of life, technology is having a huge effect on the wide range of activities our members are involved in. And today I am really happy to have Andrew Knight with me as a guest this time as we discuss some of the terms around Proptech and bring some clarity to how these terms are used and to demystify some of the jargon around Proptech. Welcome, Andrew. Please do join me.
Hi, Shaun, and thanks for having me on this discussion. And nice to be on the other side of the table for once.
Not a problem. It's good to have you, Andrew. So thank you for joining me. Can we start maybe by defining what is Proptech?
Well, it's an interesting question because Proptech arguably is quite a narrow definition in terms of the application of data and technology to real estate markets. And I know it's a very well understood term and widely used, but arguably it's quite a narrow definition, just looking at the kind of, as I say, impact of data and technology around kind of real estate as a marketplace.
Now, in a few of our videos, you've mentioned that there is something about the term Proptech that perhaps lacks clarity. Can you speak a little on that? And what do you think would possibly be a more accurate term?
Well, yeah, I suppose leading on from my previous comment about the kind of arguably narrow definition is that whilst it's a widely used term and widely applied to a whole host of firms operating in the kind of real estate data and tech space, given particularly, I think, our ICS's role, as you said, right across the built environment, all those different asset types, all those different parts of the property life cycle, I think it can be more useful to talk about the overall application of data and technology in the built environment, because what you also find jostling alongside phrases like Proptech is Contech, looking at the use of data and technology in the construction cycle. You've got Plantech, looking at data and technology in the planning part of the life cycle. You've got CRE Tech, looking at commercial real estate. You have Infratech, looking at infrastructure. And I think also, given the heritage of terms like fintech, looking at financial technology, and the fact that quite often solutions are a mixture of these kinds of technologies. There's quite often a situation you think of perhaps client money handling in the context of our ICS and our members looking after deposits and rental payments. Quite often that's a combination of financial technology and the way they handle virtual bank accounts, and the way that that's also then linked to property technology, looking at handling deposits, rental payments between landlords and tenants. So my personal view is to really be slightly more, I think, all-encompassing. I prefer just to talk about data and technology in the built and natural environment. So I'm not personally a great fan, although a lot of people understand it. I'm personally a bigger fan of just talking more generally about data and technology.
Brilliant. Well, maybe that's something we can clarify before we get into some of the meat and potatoes of the matter. What would you say is the difference between documentation and data? I mean, some organizations who may be in the beginning of their digital journey may be creating PDF documents and consider that to be digitization. How would you define digitization?
Well, yes, I think it's an interesting point there. I mean, I picked up a phrase that I use quite often from an organisation called Registrars of Scotland, who are the registrars not only of land title in Scotland, but also a whole host of other sort of registrars of ownership and other kind of legal documents. And I think what has perhaps bedeviled the built and natural environment historically is that so much of the information around buildings right over the course of their life, or assets over the course of their life, is stored effectively as documents. If you think of a lease, that typical kind of lease agreement or a rental agreement, or indeed a floor plan or some kind of visual capturing of the extent of a parcel of land, historically that has been a document. If you think back to the way buildings were constructed, they were based on written drawings. And so what we have, I think, in terms of the opportunity to digitize the sector is to not do away with those kind of documents that human beings like to look at in some kind of form, but also have the sense that as well as those documents, we need them to exist in parallel to structured data. So if that document, say it's a lease agreement, clearly will cover the terms of the lease in terms of renewal and lease breaks and rental increases and rent reviews and the various dates of termination and notice and clauses, all those kind of things and covenants. Yes, it's great to have that in a document that a person can read, but if you can turn that into structured data, that means it's much easier to report, to analyze, to understand, particularly for a large asset owner, the nature of all the leases you have. So I think we need to sort of move away from everything being only stored in a document. And as you say, quite often they're turned into a PDF, and therefore you think you've digitized the process when that information is still buried away in those documents. And there is technology that can read these documents and turn them into data, but it's not as good as having, as I say, that structured data in a kind of data format that you can analyze, as well as that human readable document that we're all used to in terms of, as I say, rental contracts, etc., etc.
Thanks for that, Andrew. Now, some of our partners deal with digital twins, and there seems to be some differing definitions on what a digital twin is. How would you define a digital twin, and how are you seeing them being used?
Yeah, you make a valid point there, I think, Shaun, that there's a lot of potential confusion around what a digital twin is. I mean, if you take a very kind of purist view, a digital twin is where you have almost a copy, hence the word twin, of a real physical asset. And also that asset can be at different levels of granularity, to use the technical term. So you might be thinking of a digital twin of a particular building, or it could indeed be a very large infrastructure asset. It could be an entire city where you're trying to replicate parts of that real asset with that digital equivalent. And I think if you're going to be a purist and talk about a real digital twin, what you need to have is that information flowing from the real asset to that twin, and then being able to make decisions in that digital twin, that digital version, that can then influence the operation of the actual asset itself. And perhaps to take an example out of the context of the built and natural environment, in a previous life, I worked with an aerospace manufacturer, Rolls-Royce, and what was interesting there was the way that they were using digital twins, and this is many years ago, to effectively manage aircraft engines, understand how they're actually working in real time, and use that then to feed back information, both in terms of operation, but also design as well. And there is a similar analogy with digital twins in Formula One, where they're used to understand how the car is going to perform, how it is performing. And I think the critical thing for a really true digital twin is that flow of information in both directions, not just getting information out of an asset, turn it into a digital copy, but also use that information to influence how that building, that asset is being run. It could be something as simple as just simply making adjustments to temperatures, to airflow, to those kind of building operation things. But the critical thing for a real digital twin is getting that flow of information back and forth, and the digital twin then actually controlling or feeding back to the asset itself. And I think a lot of people also get necessarily confused, or perhaps there can be ambiguity about the fact they think it needs to be some kind of 3D model, some very highly visual digital twin. In many cases, that is the case, that you get a gaming engine, for example, used to produce a very, very high fidelity image of that particular asset, where you can see people walking around, you can see the temperature flow, you can see airflow in a very visual way. But what's more critical is that data flowing through sensors, through other kind of ways of data acquisition into this digital equivalent, and then being used to drive and monitor change in the actual physical asset. And I guess the reason that there's perhaps also once again a need to understand how this sits against a BIM model. BIM models, building information management, have been around a long time, and they started very much as a kind of computer-aided design approach, where you could use technology to literally say, okay, we need to start building the geometry of this asset to understand the components, the slabs, the walls, the roofs, all the various elements, and make sure that actually you can then store that in a digital form to help other people understand the kind of quantities involved to produce it, the kind of assets that will be built into it. So lots of things like that, where BIM historically has started as that kind of three-dimensional model. And what BIMs are now doing is moving into further dimensions, as they call it, to look at quantities of materials required, the costs required, how long it might take to build that particular asset, and then also moving into that operational phase of understanding how the asset's performing, monitoring it. So there is a kind of a blurring, I think, to an extent where when you move into these further dimensions of BIM, particularly into the operational phase, they're very much turning into these digital twins in that way, and hence, as we talk about smart buildings, where you have sensors and those ways of really understanding how the building is performing.
Yeah, I guess that's what I was going to ask now, because it seems like there's a natural intersection between smart buildings and a digital twin. Would you say that's the case?
I think so, yes, because what a smart building essentially has is some form of kind of sensor connected devices. And there's a lot of talk about the kind of Internet of Things, where you have these sensors that are able to actually, through the internet or an internal network, connect back to these kind of digital twin or indeed building management systems to give you that real-time information. Actually, how is the building performing? How warm is it? How cold is it? What's the airflow look like? And also thinking of the kind of physical M&E equipment, as it's called, within the building, the HVAC system, how's that performing? A lot of that can also relate to preventative maintenance, understanding whether you're seeing unusual behavior in certain equipment, whether it's the lift system or the HVAC that might represent some potential problems. So these ideas of smart buildings are really about having devices, whether they're sensors connected to look at the environment of the building, movement of people, or whether it's particular pieces of machinery where you want to have that kind of feedback to be able to go in the plant room virtually and understand the dials and the temperatures, that sort of thing. So yes, smart buildings are that kind of combination of sensors, security systems, all these kind of devices that can really capture information about how the building's performing, and indeed the way people are perhaps using it, working and moving around it, utilizing it, those sort of things.
Brilliant. Now, a number of your discussions with our tech partners have touched on building passports. What is a building passport and how do they impact our industry?
Well, I think you can almost think of a building passport as perhaps being a kind of simple version of a digital twin. What a building passport really is these beginning steps of getting to get structured data about a particular asset. We've talked about this challenge of so much information being within document form. And I think really what a building passport is doing is beginning to start that journey to have that kind of digital equivalent of the asset. It may not have that kind of feedback flow that we talk about in digital twins with sensors and that kind of real-time data capture. But what it's saying is now, can we, within a digital structured database, have information that tells us where is the building, how big is it, how many floors has it got, what's it made of? Can we have copies of the lease agreements, other documents, planning permissions, if I use the kind of UK terminology, building regulatory documents, documents done by people who've come in to service the boiler or to do work on the electric. So it's building a set of information that's held digitally, that is accessible very easily, that you can search, that you can report on, that begins to build this kind of digital picture of a particular asset. And I think in our context, it's about thinking about how they can be used in the sense of supporting perhaps better upfront information for buying and selling properties, better information to understand whether a building can be rented out, for example, in terms of licensing and safety considerations, thinking about fire safety in the context of the unfortunate fire at Grenfell, for example, having information available for emergency services for them to understand floor plans, exits, where the risers are, whether they're wet or dry, all those kind of information that helps people interact with a building in this kind of passport logbook, as they're called. So not a digital twin perhaps in the purest definition, but an understanding of how we can begin to have structured data around a property asset to support a number of things. And perhaps to finish on this point, with a lot of focus on retrofitting buildings for sustainability point of view, having information about what's possible, energy usage, current levels of insulation, those kind of things that help people understand what they can do with an asset.
That's great. All right, well, to touch on something else that you've spoken to our tech partners about, software as a service. Now, this has come up a few times as well. What is it and how is it different to other tech solution business models that have preceded it?
Yeah, I mean, it's become a very, very common way of kind of delivering technology now, not just within the built and natural environment, but more generally in terms of services that we all use at home or at work. And if we almost wind back a few generations, I'm old enough to remember the days of green screens where all you did was type in a terminal, and your interaction with the computer system
Yeah.
was pretty primitive, compared to most people's experience now of how they interact with phones or with computers. And well, after we had the kind of green screen interface, we also had something called client server, where you'd have a PC and your laptop or a standalone machine, and that would connect over an internal network back to some big server in the basement somewhere, and that would provide you with your database and run the programs and that sort of stuff. And some of the programs would run on your laptop, some would run on this sort of server buried somewhere in a basement. And really, once the internet took off, I think, as a really kind of reliable high-speed connection, the next kind of natural step really was to sort of effectively kind of host not only the programs but also the data that those programs look at, really as a service via the web browser. So often now we interact with software effectively by going on to Google Chrome or Microsoft Edge, logging into a website and interacting with the program and also the data there. And what I think is inextricably linked with this concept of software as a service is this concept of cloud computing, where they're not physically in the cloud, they're in a physical data center somewhere.
Yeah.
But actually what we're doing is we're using software and the data that is being manipulated and worked in that software product. They're all sitting in these various cloud services, and yes, they're distributed. They'll be there'll be replicated copies, but effectively we'll be using a computer and the data storage that goes with it in that sort of cloud. And what it means when we now then talk about software as a service is that when, as a customer, you want to use a particular product, you probably don't have to install anything on your local machines apart from having a web browser and an internet connection. What it
Yeah.
means is you've effectively moved that sort of overhead, that infrastructure, onto these cloud platforms. So typically a software as a service provider will use a particular cloud provider to host their product, their software, the data that you have, and therefore you access all of this functionality, the program and the data, as software as a service. And I think also, as well as the technical piece, it's probably worth highlighting that so often this now means that you'll be paying on a kind of subscription basis rather than necessarily buying a license for the software. And that way you're buying it on almost as a pay-as-you-go subscription basis. And in many cases, it might be quite flexible, that you might only have to give a month's notice, for example, depending on the commercial terms the supplier has, but you're subscribing to a service which is provided wholly over the internet.
So instead of a large upfront outlay, you might just have smaller installments ongoing.
Exactly, yeah, and that's been a challenge, I think, to some large, well-established software providers who were used to a more sort of upfront license fee and then maintenance, and this is more a long-term subscription type model. So it's been a challenge and an opportunity to the software industry, but also I think potentially a real opportunity, and I think particularly for our profession, where if you're not a large firm and you don't want to have your own servers and all that kind of infrastructure and an IT department, a lot of what you want to use now you can simply use as software as a service, so you don't need to install all that infrastructure.
Brilliant. All right, if we can touch on another topic that's come up in a few of our discussions, AVMs. It's a term that we're hearing more and more about. What's an AVM and what are the benefits?
Well, an AVM is an automated valuation model, and like a lot of terms, there can sometimes be some ambiguity about what it exactly means. If you take, I think, a reasonably kind of purist view, a fully automated valuation model is one where you want to value perhaps some residential properties, and you simply input the property information in terms of the assets you want to get a value from, and that process is then, as the name suggests, 100% automated. The number comes out, the value, and there's no real human interaction. I think what can sometimes muddy the water around this discussion is that quite often AVMs may well be used as part of a more hybrid process, where a valuer may use the AVM input as a checksum or part of the overall process that a valuer comes to. So there are still, I think, misunderstandings in the market about how AVMs are used, and the fact that there is this kind of hybrid model emerging quite often where they'll be part of a valuation process, and there may well be some human involvement. And clearly there's always human involvement in terms of writing the code, the actual programs that these AVMs run. So there's certainly human activity in terms of writing these programs, but quite often they are run in a very automated way. Although having said that, one of the most obvious and common uses of AVM is in secured residential lending, where a bank lender or mortgage firm will use them as a way of, perhaps for at least perhaps half the mortgages they originate or remortgage, that they'll use it as effectively a risk management tool to understand, well, okay, these are the properties we want to offer a mortgage on, which ones should we actually do a physical valuation on and do a site inspection and a condition report, and which ones are we happy enough that fall within the range of our appetite for risk, just to take the number that comes out of the automated valuation model. They're used mainly at the moment on residential properties. The way values work, as many people know who will be listening to this call, for commercial is very, very different in terms of the characteristics of commercial real estate, but there are AVMs being applied to non-domestic properties, looking at the characteristics, and certainly for things like property taxation by governments. Quite often these automated valuation models are being used for the kind of banding approach to look at not only residential but non-domestic premises as well. So I think we'll hear more about AVMs as they become increasingly used, not only in the UK and US but other developed economies. One thing you do need for AVMs, as a passing comment, is good data. The AVM is kind of only as good as the data it's able to look at in terms of prices paid and the kind of characteristics of properties as well.
And is there any concern that AVMs are going to be possibly replacing property professionals?
I think to an extent that they will what they will do, and what they've already done in certain economies, is allow the valuers to focus on the more unusual properties, the properties that fall out of the process of an AVM, where actually it requires a valuer to do that more traditional, if I can use that phrase, valuation, to go and perhaps visit the property or do a test stop valuation. So I think what we'll see is situations where the valuers will perhaps move away from doing the very homogeneous, the very similar properties, and be focusing much more of their time on these arguably more interesting properties to value. And there are certainly contexts where AVMs are being used for looking at portfolios, where realistically there probably aren't enough valuers out there to do a job, where somebody says, actually, we've got a portfolio of mortgages here, we'd like to get some sense of the value of that portfolio, and there are 10,000 properties. Now, it's not realistic for human valuers to actually go out and do that scale of valuation in that way. Hence, they're used quite often in these mass appraisals for property taxation. So I think they will certainly change the role that valuers have, particularly in residential property, where they'll be much more used, I think, to look at these more unusual properties that AVMs aren't really suitable for.
Well, PropTech is one of those industries where buzzwords sort of pop up every now and then, and at the moment, well, for some time now, some of those have been AI and machine learning, and they're often referred to as features of a product or a tech solution. What are they to your mind, and how do you see them impacting the work that our professionals do?
Well, these terms, as you say, are used a lot, and they can be confusing and difficult to interpret. I mean, the concept of kind of artificial intelligence has been around for a long time. I mean, Turing defined it back in the 50s in terms of the kind of thinking machine. And there've been attempts, past century, the latter part of the last century, to create things called expert systems, where they try to put in to the computing power of the time the ability to understand the characteristics, particularly of perhaps medical issues and diagnosis. So the concept's been around a long time. Funnily enough, one of the things that's really driven the growth of AI and these kind of techniques in recent years has actually been gaming technology, where the kind of computer chips that were developed for graphic processing proved to be powerful and able to process instructions in parallel at the same time, and have lent themselves very well to really increasing the power that's been placed in programmers' hands to now develop this sense of artificial intelligence. And I think it's worth putting, I think, a limit on on the ambition at the moment of what artificial intelligence does. It's not creating what's called general intelligence. It's not creating people with the kind of thought processing skills of human beings. What artificial intelligence in all its variations is very good at is learning to do very kind of specific tasks. And we're already seeing some of the boundaries of that, some of the challenges where people have been talking for a long time about driverless cars, but we're seeing that that's actually quite a challenging thing for artificial intelligence programs to do. What they're very good at is searching for patterns, looking for, as I say, repeated patterns, analyzing data. They're very good at being trained on data sets, for example. So when it comes to things like visual recognition or looking for certain characteristics, if you give these models a lot of data, they can be trained and learned, hence the phrase machine learning. They can learn to recognize things, and they can learn to extrapolate and make some very, very good decisions. And they can also be used to take out some of the human bias. If we think about recruitment systems, if they're properly designed using machine learning, these kind of AI techniques, they can be very good at taking out some of the human bias in the decision making. So they're not a silver bullet. They have limitations, but they are very powerful, and they're capable of running effectively, calculations in a way that would take a human being years to do. If you think of perhaps modeling the different variations on a theme of how you could schedule a large construction project, there are probably thousands and thousands and thousands of possible permutations. What AI is very good at is running all through those very quickly and understanding the pros and cons of those kind of methodologies. So they're very good at applying these kind of repetitive statistical approaches to looking at data. So they will have, and they already have, an impact on the work our professionals do. But I'm always an optimist in this sense, and I think what they will be doing is augmenting what our profession do. They'll be making a lot of the data gathering and initial analysis a much more automated feature, and I think in a positive sense, allowing our profession to use the outputs of many of these AI and machine learning techniques to actually free them up for where they should be working, which is this high value advisory advice based on data sets that perhaps have been crunched by AI. And I suppose back to some of the discussions earlier about BIM and smart buildings is we are dealing with quite big data sets, big data as it's called, sort of volume, variety and velocity of data coming in. And that's another area where AI is good at dealing with these huge volumes of data, sifting through, looking for patterns, looking for important trends that would take a human being their entire life. So a lot of positive value, but they're not going to replace professionals. Quite often they'll be, replacing some of the more mundane tasks, dare I say it, and leaving the professionals freer for other issues.
That's really interesting. ESG is another term that I've noticed coming up in our discussions recently. What is it, and how is it being impacted by tech?
Well, I mean, it's an umbrella term for almost a sort of a set of drivers that have come as much perhaps from the sort of capital financial markets, looking at how companies and organizations conduct themselves. ESG, as hopefully most people are beginning to be aware of, stands for environmental social governance. And it's really around three pillars, particularly looking initially at how companies perform. What environmental impact is a company having across all its operations? What kind of social value, hopefully in a positive sense, is it having in terms of the stakeholders it deals with, in terms of customers and employees, the broader community in which it operates? And then that last piece, the G, is the governance. How well run is this organization? Is it transparent? Is it being governed in an ethical way? And as I say, there's a lot of funds out there. There's a lot of people now investing specifically in what they consider to be well-run companies, well-run organizations, where they're addressing all these three pillars: environmental impact, social impact, and governance. And it is driving performance in terms of investment and driving performance in terms of understanding that we want companies, organizations that have a positive impact across all those pillars, not a negative one.
And the environment's always going to be a continual concern, especially around sustainability and goals for net zero. How do you see data and tech in the built environment specifically playing a part in that?
I think it's almost the most critical piece, because we need data, and then we need the technology to work with that data to really deliver savings and the performance that the built environment needs to deliver. I forget the exact statistics, but clearly the built environment has a very currently negative effect if we just think of carbon in terms of embodied carbon when assets are constructed, and then the operational carbon. So it's critical that we have a better understanding of all the existing assets, a better understanding of the assets that we're going to build in the future, and a better understanding of how we operate them. And that's going to be critical, that we need to have data. We need to understand what's the embodied carbon of the choices we have when we build a particular asset to inform those design choices. And once those buildings are then created, we need this data, whether it's a smart building, a smart asset, to work out how we can optimize how that building operates, minimize the waste, minimize the amount of carbon that's produced by managing the HVAC and the heating and all those other systems. And then if we think of the kind of the concept of the circular economy, we need to understand once again, how is that asset being constructed? What kind of materials can we recycle at the end of life? What can we reuse? Minimize what goes into to landfill, and make sure that over the full life cycle of an asset, we're minimizing its impact, as I say, both in terms of embodied carbon, operational carbon, and then waste at the end of life. So without that data, we can't manage. So I think data and technology will have a critical role in making sure that the built environment really begins to clean up its act, maybe as a phrase to end on.
Well, thank you so much for your time today, Andrew. I found this really interesting. I hope our viewers have as well. Is this something you'd like to do again sometime? Maybe we'll find some other subjects we can do a deeper dive on.
I think indeed that there's always more jargon and more phrases being used. So yeah, look forward to having another session, Shaun.
Brilliant. Well, thank you very much today.
Pleasure.